Okay, next item is item C, presentation by HDR Engineering regarding Lynn Lane Wastewater Treatment Plant. Kenny?
Yes, thank you. We have Joel Cantwell from HDR here. Back in August, the city staff went through a selection process on different engineering firms. They interviewed and selected HDR to take a look at the Headworks, and he'll go into more detail on that, the screening and the grit removal. Staff at that time interviewed several firms and just said HDR's knowledge of the wastewater treatment facility and their proposal to address some, I won't say unforeseen issues, but additional issues, basically put them far and away the top candidate. So at this time, I want Joel Cantwell to come up and make the presentation on it.
I appreciate the opportunity to be here tonight. Again, I'm Joel Cantwell with HDR, and mine is also going to be about 8 minutes tonight. So Kenny talked about a lot of issues that are facing the city. I'm going to delve into one for a few minutes, and that's the Headworks at your Lynn Lane Wastewater Treatment Plant. The three topics I'm going to cover is to show you what the existing facilities are and what the issues are with those facilities. The alternatives we looked at to improve the facility, and then the recommendation. Okay, first the existing facilities. This schematic shows from left to right on the screen the flow of the wastewater through the Lynn Lane plant. The influent comes in to some screw pumps that lift it out of the sewer. It screens, grit removal, another lifting step, then into your biological process. Finally, your chlorine contact to disinfect it, and then it's discharged into the Arkansas River. And so that is the liquids treatment process at the plant. The processes at the bottom of the screen are the way that you handle your solids. But what we're talking about today, the Headworks, is defined as the preliminary steps of treatment. It's really the physical treatment. You're removing rags and, we call them floatables. I won't go into any more detail of what that is, but and then into the grit that's coming into the water. And all of those things, if you don't get rid of them correctly, they're going to cause all kinds of havoc downstream through the rest of your plant. This is an aerial, and you can see the red arrows show the flow stream through the plant. It comes in from the far side of the screen into the screw pumps where it's lifted into the bar screen building, and it goes to grit removal to the north, over to the other screw pumps, and then it's pumped back to the south to the rest of the process. Some of the issues with these things, it's aging infrastructure. One of the drivers that you mentioned, these are over 30 years old. They were constructed in 1984. It's a very corrosive environment. It's a tough duty that these processes have to do for you at the plant. The equipment, electrical gear is at the end of its life. It's aged, doesn't have much left, and it's a really big source of odors at the plant with the screw pumps just churning the wastewater as it carries up into open air. Here's a picture of those screw pumps at the beginning. You can see the pit on the left. It's where it comes in. You can see all the accumulation there of trash where it doesn't have anywhere to go, and the water is lifted up. It's a major source of odors, just open to the air. And that, if we had a video, we could show you, but this is a screw pump. It's turning and it's sloshing the water, and so the H2S is escaping into the air. It goes into the screening building. On the right is the condition of one of the two screens that are there. It's out of service right now. It's at the end of its life. You can see the condition of the rest of it. The electrical and HVAC systems are at the end of their life, and it's a very corrosive environment. The screens have been very unreliable, breaking down frequently. Onto the grit removal. In the bottom right-hand corner, you can see there the water, and that's where the air is added into it to remove the grit. That actually has not worked in several years. It's not really removing grit right now. It's actually not even ideally sized to be able to remove grit for this facility, so it just doesn't work very well. On top of that, the equipment is at the end of its life again. The electrical systems are corrosion has taken place, and so that the equipment and piping needs replacing. And then the last step in the Headworks, it goes on to the second screw pump station. Now, this was added in the expansion, the last expansion of the plant that went into operation in 2008, and that's because of the downstream processes. You had to lift the water further to get it to that area so it could go ahead and flow by gravity through the plant. So it also, under those grading that you can see at an angle, there are more screw pumps there that are actually, that's just grading over it, so they are open air as well. So it's another step there where odors are being released. A big issue with this plant, you can see, and that is about a little over 400 feet from the north fence of the plant to the nearest residence. And there have been numerous odor complaints from the neighborhood there, but from many houses that are further away than that closest house is. In 2002, a study showed that 98% of the odors generated at the plant are coming from the Headworks facilities. Okay, now I'm going to look at the two improvement alternatives we did. The first is to rehabilitate the existing systems, and the second is to replace those with a new combined Headworks facility. This just shows, if you take the black and white background is your existing screening building, and the shaded portion is what would be improved. You could insert two new screens into the channels, take a conveyor over to the right-hand side where we'd build a new part of the building to add compactors there to do a better job of squeezing the water out of those, sending it on, and drying those out before they hit the dumpster. That entire building would then be enclosed, and HVAC system would be put in place to ventilate it, make it less corrosive inside so that equipment would last longer, and the electrical gear would be replaced. The construction cost for that would be about $2.7 million. This just shows, this is one that we just designed, and it was just built at the Stillwater wastewater treatment plant, and it just shows what kind of the updated equipment and how everything is contained. It's screened there, it's contained, it goes into a contained conveyor, into a compactor, and then into the dumpster, and it comes out very dry into there, so it really reduces odors, and it's a lot cleaner installation. That's an example of close to what it would look like. This is the grit removal facility. Again, the background is your existing facility, and we would propose, if you see the two circular parts there, those are called head cells, and it's a new technology for grit removal that's much more effective. It gets down to that finer grit that really causes havoc with the machinery downstream, and a lot of maintenance, and wears out your equipment sooner. We would propose to install two of those, and onto the right side are two grit washers, and it's a step above what you have now. You would actually, they wash the organics and the grease that is on these grit particles back into the waste stream where it's treated downstream biologically, and what comes into the dumpster is kind of a clean sand look. And so that's where all the odor comes from grit when it's in a dumpster, the organics attached to it, and this would wash that off of that before it gets into the dumpster. We replace electrical, HVAC, grit pumps. Then the last requirement is the Oklahoma Department of Environmental Quality has a buffer for wastewater plants, and you can't have any process within 100 feet of the boundary, and this is much closer than that. And so to upgrade this facility, you would actually have to purchase some additional property on the north side to make sure that that buffer zone is in place. I suppose this was built when you either got a variance for that buffer or it wasn't in place at the time when you built this.
Buffer from what? From the houses?
It is from the property line of it. And so where this grit facility is within about, I think, about 30 feet or so of the property line there. So you have to have a 100-foot buffer zone between any process building and your boundary.
So we'd have to extend our boundary to the north?
Yes, you would.
Okay.
Yes.
How far did you say?
I think it's about 30 feet, so it has to be 100. So you would have to buy a strip of land that's at least 70 feet, possibly more, to the north.
But are you going to add structure to the north as well, or?
Yes, if you see the red part on the north side of that building, the top side is actually, that would be an expansion of it. It ends there where the white is. The one on the bottom side is actually installed inside the existing footprint, but then you would have to go further north, so yes.
So does that not put it closer to the residential?
It does. Yes, it does. That's why I'm not going to recommend this later on. One of the big reasons.
Well, gee. Okay.
It's like being up the optometrist, which
So the estimated construction cost here to improve the grit facility is $4.3 million. This is just an example. This is a new technology. My company, we're designing the largest one in the world right now. It's a 300 million gallon per day Headworks at a plant in Dallas, and so it's the largest installation of these. And so we've had a lot of close-up experience with. Half of those have been in operation for about a year. The other half of those will be coming up pretty soon. It's made a vast difference to the operators of that plant. So, again, there's your existing layout, and you can improve them like I just showed you how they could be improved, but there are still some issues with the existing layout. It was exactly what you just mentioned, that these odor-generating facilities are on the far north of the facility, and it's close to the neighborhood where these odor complaints are being received. It's a very long path. It's not a direct path from coming in to getting to the further process. You're actually dog-legging to the north and coming back. And then, you are pumping the sewage before you screen it, and we typically, these days in a new Headworks, we would screen it first, get all that out there before you expose it to your mechanical equipment to pump it. And again, you're pumping the flow twice. You have two of those screw pumps that are causing odors. You're doing it twice. So the second alternative is to construct a new combined Headworks facility just to the south of where the bar screens are now. So this would combine influent pumping, screening, and grit removal into one area. When you do that, you would be able to then demolish those facilities up there and really clean up the site. Now you have a direct flow path into the rest of the plant, and you're keeping those further to the south. So what this does for you, we've talked about most of those things. Yeah, and it does open up that space, whether you want to put a maintenance building up there or it needed another clarifier or something like that down the road. Estimated construction cost of building this new facility is $9.2 million. Just kind of roughly what it might look like. If you see to the left, that's where the sewer will be coming in. That's actually going down and capturing it at the level that it comes in, and you screen it there. And then it flows down a ramp into a wet well where those are the pumps, and those are the influent pumps. And they do the same pumping that both of your screw pump stations are doing now, but they would be in a contained wet well, and so there's no odors caused to escape there. Then it would then pump through that pipe at the bottom of the grit facility, up into the grit facility, go through the head cells, and flow by gravity on through the rest of the plant. For a recommendation, so here's a summary of the alternative costs that we just looked at. To rehabilitate, screening and grit's about $7 million of construction. To build a new combined facility, about $9.2 million of construction.
does to rehabilitate the existing, does that include the purchase of the additional land?
You remember, Roger? I don't think it does. That's just a construction cost.
So would be an additional cost?
Yes, it would. Yes, sir.
So do both of these options do away with smell?
Well, so
So
there's a
so
separate.
the answer is no.
Well, they improve it quite a bit
So the answer is no.
Well, there's a separate capital project planned
Of
to
course.
add scrubbers to these. And I can show you what we did here in this next part. This is where we made them apples to apples. And because when you build a new one, you're getting some benefits that you're still not getting if you rehab those facilities. One of those there at the bottom, you would have to improve those screw pump stations to be ready for odor control. You would have to cover them, then you would have to add some pumps to get up to the same capacity that you're going to need in the future. And then on the odor control, you can see it's a little bit less for a new facility because you would have one scrubber to handle all of it, whereas now you would have to have one by screening, one by the grit, and it costs a little bit more to do that. So it's my understanding right now that this project does not include the budget to add that actual scrubber, but we would put in the ventilation and we would put in the ducts, the air ducts, so that that scrubber could just be added and tied right in. It would start scrubbing the air. But I mean, we would fully expect odors to improve because we're cleaning the screenings better and we're cleaning the grit better before they're deposited. We're keeping those organics in the water.
So we're spending $1.4 million to improve the odor control for people who build houses close to the sewer treatment plant who shouldn't have built houses close to the sewer treatment plant. Just an observation on my part.
So that cost there, they're pretty leveled up when you do that, so it's about 10.6 million to 10 million. We also took a look at advance. Yeah. Okay, so we also took a look at, you know, some of the kind of non-economic comparisons between the two, and there were several advantages to building a new one. It does move them further away. It eliminates the screw pump stations, and that really saves power costs. It saves a lot of maintenance for the staff there, and it reduces your odors. Just getting rid of the screw pump stations would greatly reduce the odors that are generated. But when you slosh it like that, it causes the H2S to come out into the air, and the way we would be pumping it now does not. Centralizes your future odor control. That's a self-cleaning wet well, reduces maintenance. You would screen before you pump. And then we were talking about this with the staff today, there are a lot of trickle-down effects from improving screening and grit removal. Because when you don't have it good, as they're seeing now, the stuff accumulates in the pumps downstream, in the basins, and in the digesters. And they're constantly having to pull rags out, and grit accumulates. You have to take basins down, clean them out. You know, it's very expensive and time consuming. So it makes a lot of improvements. The City of Dallas grit installation that we did, they've seen a really, I mean, it's going to save them millions of dollars a year in just pulling grit out of their digesters that their facilities weren't removing.
So this new plant, the new one you're talking about, would also be increased for our future capacity?
So it would actually be designed, that cost includes designing for the future capacity, yes.
So that's the big key of going to the new plant, is that we would have capacity.
Yes, yes, it would. It's designed, and we're actually in a separate project right now. We're doing the wastewater system master plan. And so we have determined through modeling really we're calling it build out of your existing comprehensive plan. If you implemented your comprehensive plan, what would your flows be at Lynn Lane? And that's around 25 million gallons a day, 24 to 25. And so this would be designed to handle that. This new concrete would also have longer life because structural codes for concrete and rebar are more stringent than they were 30 years ago. And so it would have a longer life. Another advantage is, you know, if you rehab your existing facilities, you have to take those down and you're getting no treatment in preliminary. This can be constructed alongside it while those stay in operation. And so our recommendation is to construct this new combined facility. I'll be happy to answer any other questions that you have.
Questions?
Well,